And okay, yeah, so it is starting to record, so that is cool. So we'll share the links will be online again. So if you guys are, obviously you must be on the MS with Teams if you're in the session. There is in the Teams page, if you go to recordings, there are links to the recordings there, and it will be under the DSC1520, and you can download the recordings as well. I think it's only the first 5 that you can download, but all of the other recordings are there as well. Okay, so let's get this one going. So let's try to finish assignment 3 today. Then I was looking at the calendar, and let me just quickly pop that open again. And I think you guys are writing on Tuesday, or next week Tuesday, so not get a heart attack now. It's not the 23rd that you're writing, the 30th. So we've got another session on the 27th. I was thinking that somewhere in the week, so this coming week, I'm going to see if we can maybe schedule another session for you. And then nearly the 29th. What time are you writing on the 30th? So anybody can quickly just shout out what time are you writing? If you know.
Morning, John. I think
Morning.
it's from 8:30.
Okay, so
but it's the morning. It's the morning,
okay.
so the early morning.
So okay, cool. So I was thinking that on that Monday, we can also do a session, but it's more like a question and answer session. Nothing that I'm gonna prepare unless you guys send me some questions beforehand over that weekend. But otherwise, it's like a question and answer session just to calm the nerves as well. So I was thinking sometime next week a session, and then the 29th just as nearly a check-in session with you guys. So I'm just going to make sure that I get that set up, and then we'll communicate it to you. Okay, so let's start with trying to finish assignment 3 today. Then we'll look in the week. We'll look at the exam paper one that was shared on the group as well. And then I think that is then good preparation between assignment 3 and the exam paper to nearly be ready for the exams on the 30th. Okay, so let's start with question 20. I think we finished question 19 last week. Yes. So the question is: a 200,000 car depreciates linearly to 40,000 in 8 years' time. Derive a linear equation for the value of a car after X years, with X smaller or equal to 8 and bigger or equal to 0. Okay, so basically what you do with this one is, and I'm now thinking if there is a sneaky way to do this as well, but let's first do it the way I would have done it. So let me just get into my. So you basically have 2 points. So they tell you a car depreciates linearly to 40,000 in 8 years' time. So you basically know that in 8 years' time, a car will be 40,000. Okay, so that is your one, and then I'm just trying to quickly get onto that I can see the chat as well. And then the other one you have is at time 0, the car is 200,000. So you can work out the slope with that. So basically you can work out the slope, and the slope is normally the difference in y. Okay, sorry, I just want to quickly log into my phone onto this so that I can follow the chat. Obviously there's now lots of security, so let me just, okay, cool. Yes. Okay, cool. So there is the answer as well. So basically the change in y over the change in x, and with the y it is, or with that, you can, so normally one would say the y2 minus y1 over x2 minus x1, so that would have been x1 y1 x2 y2. So that is your normal one that you would use, but there is not, if you do it the other way around, you will get to the same answer. So if you said y1 minus y2, you will also get to the same answer. You must just remember that at the bottom then you also say x1 minus x2. So if a top one is negative, the bottom one will also be negative, so the two negatives will in any case cancel out. So it's not about which one you use first. Just make sure that whichever one you use first at the top, you do the same at the bottom. Okay, so then we have a difference in, so y2 minus y1 is 160,000. I hope I'm doing my sums right. And the difference in the x's is 8. So it would have been 8 minus 0. And that then is equal to, so if you say 160,000 divided by 8, you get minus 20,000. So if we did it the other way around and said the 200 minus that, it would have been positive 160,000 above, but then the bottom one would have been negative. So you would have gotten the same answer. Okay, so we know then that that the slope is the 20,000x. Okay, so if I then look at, so the minus 20,000, so then if I look at these options, it's not that one, it's not that one. Okay, so again, if you then need to decide between the two, it's an easy one to say, okay, it's between 1 or 2. And then if you look at it, and I think that is also the question, but how do you okay, yes, and then the other thing, so you basically now have this. So the minus 20,000 x plus c. Remember, your c is where y is equal to 0. So sorry, where x is equal to 0. So if you had your diagram, or it would have been where x is 0, that is where c will go through. Okay, so that is your y cutoff. And so where x is 0, c is equal to 200,000. So your formula would just have been minus 20,000 x plus 200,000. So if you then put in x as 0, you will get with 200,000. Okay, so the option was option 1 for this one. Okay, happiness with that. Anything that I quickly need to show again? It would have been interesting how they got to the, what is that? That's not even 4 million, it's 4 billion. It would have been interesting how they got to that number. So maybe it was more straightforward. So probably if you said x is equal to 200,000 times with 20,000, that probably got you the 4 billion. If I quickly look at it. Okay. If there's happiness with that, we go on to question 21. Okay, so here we basically need to find out what the x values is, and here you can use in 21 Mohammed's way. So you could have said, if I put in 0 into x, do I get 0? If I put in 4 into it, do I get my answer? If I put minus 1 into it, and if that one is not right, go to the next one, go to the next one, go to the next one. Okay, so that could have been a way of doing it, but I just do, firstly, what I would do is factorizing it. So there's an x in all of them, so I take out the x. So what is left here is x to the power of 2. So we know that is sorted out, minus 3x. So we know that is sorted out, minus 4. Okay, so even before I go continue, with x being there, I know one of the answers must be x is equal to 0. So I automatically go and say, okay, that one can't be one of my options. So then I continue. So I hope I don't need to use the equations. I hope I can just calculate it by factorizing it. So how to get to 4, you can say 2 times 2 will get you to 4, or 4 times 1 will get you to 4. but we need the -3 in the middle. So if I say 2 times 1 will give me 2, or wait, let me just, not, so that can just be 1 times 1. Okay, so if I say 1 times 2, 1 times 2, so that will probably all give me 4 in the middle or 0, so that won't work. If I say 1 times 4, it can give me 4. 1 times 1 will give me 1, so that at least can tell me, okay, 4 minus 1 can give me the 3, or 4 plus 1 can give me the 5. So at least I know there's a minus, there's a 3 that I can get. Negative there, so 1 must be negative, 1 must be positive. That answer is negative, so the biggest one must have the negative sign. So the other one will be the +1. So then out of this one, x minus 4 is equal to 0, and x plus 1 must be equal to 0. So x is equal to 4, and x is equal to -1. Okay, and then we're sitting with option 1 as the correct one. Okay, so if you were in the exam and you put in the 0, you would have gotten 0, because 0 to the power of 3 would have been 0, that would have been 0, that would have been 0. If you put in, let's first say, the -1, so that would have been -1 to the power of 3 would have been -1. -1 to the power of 2 would have been +1. +1 times -3 would have been -3. -1 times -4 would have been +4. So there you would have seen that if you add those together, it would have been 0 as well. So yes, you could have used Muhammad's way of what he says is his Scully method, and you would have gotten to the same answer. The problem with that, again, is if that right answer was at the bottom, you would have waited, or you would have worked through a few of these to get to that answer. But there is, if you can't factorize or don't want to factorize, there is another method of doing it. Okay, are you guys happy with question 21? Then we can go on to 22. Just give me a few thumbs up in the chat, and then we can go on to the next one. Cool. Okay, so the next one, and this now is again a more difficult one. So it is differentiation, and nearly again when I look at this, we're going to use one of the differentiation rules, but nearly if I look at this, there's going to be 2 terms. So that is going to be 1, and that is going to be another one. And we know with E, that is normally, there's not a lot of things that change there. But if we need to differentiate this one, there is going to be another term. So if I look at these answers, I nearly want to say that one won't be one of your answers. Because when you start going to differentiate that one, you're going to get a different answer. So I nearly want to say, when you look at the answers, you nearly know there's going to be two functions in it. So that is my first thought when I looked at this. But let's work it out. So what they normally tell us is, okay, let's make the one equal to, let's say, u, and let's define the other one as, let me quickly just erase that again so that we can just, and let's define the other one, let's say v, but you can use whatever you want. Okay, so basically now we sit with a product rule, and the product rule basically tells us that, so let's just write it out, that you're gonna need to say, and let's first write it, sorry, so you're going to use the first one as is, and you're going to multiply it with the derivative of the other one, and then you're going to add it, and see, because there's the add, you nearly can't have that, because that tells me that I am going to have another term. So then it is v times the derivative of the first one. Okay, so it's u, which is x3, the derivative of e to the power of 2x. So can anyone remember what that rule is? So, and that is, I've had a few questions. When the formula page will be done, I'll send that to you guys. Hopefully by tomorrow, I will have that finished. Okay, so the derivative of that one is, so that nearly stays the same, but the 2 that was there also comes up in front. So that is just that rule, but I will in the rules that I'll send to you, I will just write that in there as well. And then the other one is, so we're sitting with v, which is ex, and the derivative of, wait, not multiply, not plus, it is multiply. So the derivative of x to the power of 3. So what is that? So can anybody tell me what that will be? Is that right? Are you guys happy with that? Let me just quickly get a check in before we continue. Is everybody happy at this stage where we are? Okay, awesome. Okay, so then basically, let me see, what do I have in all of these, and I look at the answers. So let me see, I've got the x to the power of 2, x to the power of 3, so I can take out x to the power of 2. Then what's left in this one is x. I'm just going to write this one still out as it is. Yeah, I'm left with 3e to the power of 2x. Okay, so then in both of them is e to the power of 2x. So again, I'll take out 2x e to the power of 2x. So what is left in this one is 2x. That's for that, and what's left in this one is 3. Yes, share that calculator on the WhatsApp group as well, because you are allowed to use some of the calculators and online calculators to work out this stuff. I would highly recommend any calculators that you can use on any of your devices. It is nearly the golden opportunity to be able to use online calculators for this exam. So basically then it would have been option 4 as the right answer. Okay. Yeah, so please, I'm all for calculators that can assist you in the exam, especially with these questions, and especially if you can find a derivative calculator, because if I look at this one, it's going to take time. So it's not that you can just look at it and get to an answer. So so I think I'm going to skip 23 now. Let's just see if we can run through the others, and then I'll come back to 23, because it is quite a long calculation if you work it out from scratch. So let's come back to 23, that we can rather run through the other ones at a quicker pace and then come back to that one. Okay. So let's do 24. Plane takes off from an airport at sea level, and its altitude at time t is given by a formula. Find the rate at which it is climbing at t equal 3 minutes. Okay, so how would you guys do this one? Is there any takers for this? Okay, so basically what you need to do here is you need to find, and yes, first derivative. So you need to find the derivative of that equation. And remember, ln of t is, and that is again one of the formulas. So ln of x is always then 1 over x. So ln of t will be 1 over t. So basically we need to, if you replace the ln of t with that, you've got 2000 divided by t. T is equal to 3, so it's 2000 divided by 3, which will give you, let me just quickly, I think it's the 6666 one. Yes, so 666.67 or then 0.7. So it is option 4. So there's basically not really a catch in here. This is straightforward. You just need to know that you need to do the first derivative. You could have even said, let's quickly, I just want to quickly see if So if you just replaced, and luckily there's not a answer for that. So if you just replaced the t with 3, your answer would have been, and if I now worked it out correctly, your answer would have been something like 2,100. So normally in the exam, there would have been an answer like that for you as well. So if you just substituted the 3 into t in your normal formula, there normally will be an answer for that as well. So here's straightforward. First derivative, you replace the t with a value and you get the answer. Okay, so let's look at 25, which again is integration. So remember when we looked at the integration questions, there was always the plus c that we added when we worked through the examples in the study unit. So I nearly want to say that if you will get one of your answers need to include the c, so it is 1 or 3 will be your answer. Okay, so that for me is just how I would have first looked at it, is to say, if I need to integrate, I know there's always a c that I will need to add. That's the constant that falls away when you integrate. The constant normally falls away, so you always need to nearly show that. So it would have been 1 or 3. So let's look at, that's quite an interesting one, because that is exactly the same. Okay, so what I would do then first is to say, let's all of them has a t in them. So I would first try to simplify this one. So I would not now try to say there's one term at the top, one at the bottom, and then need to do something difficult. So for me, all of them are t, so I would first just write them out that we know what we are dealing with. So that is t to the power of a half, then we're dividing by t3. Okay, so t10 divided by t3, so it would be 10 minus 3. So we will be sitting with t7. And then that one would be, so we will do the same with that. So it is a half minus 3, which is then minus 2.5 if I am working it out correctly. So let's just see what are the options here. So they are keeping it in that form. So that is how I would then keep it as well. So maybe just for now, because there's also a square root there, let's make it 5/2, just so that we, okay. So that was the simplified formula that I will need to integrate. Okay, so again, integration. So we add 1 to the top, so 7 plus 1, but then we need to divide by 8. So that is t8/8. So that one is correct. If you say 1 divided by 8, you will actually get that. So at the moment, I can't yet say if it is 1 or if it is 3. Then let's just see I made a mistake here. I didn't. Okay, so there needs to be a negative in front, and maybe that will change signs and things like that. So, okay, so if I then, yeah, I need to say, okay, t negative 5 over 2 plus 1. So it is, let's just say it plus 2 over 2 so that we can do it easier. So that then is equal to minus 3 over 2. Okay, so we have quite interesting. So I would have gone with option 1. So let me quickly see. So the positive state, I made a mistake. So let's just, and how easily one makes a mistake there. Sure, and for that mistake there was an answer. Okay, the original had a minus, there was a minus. At some point I changed it into a positive and shouldn't have. And I would have, if I continued with that, I would have chosen option 1. So it just shows how quickly I made a mistake from that to that point. Okay, so negative 3 over 2, so that is, I need to divide it by the negative 3 over 2. So let's do it like that. Negative times a negative change into a positive. Okay, and at the top then we sit with the t minus 3 over 2. Okay, so already we know it's positive. It's positive, so option 3 is your correct answer. But let's just, so that stays the same. I'm not going to rewrite that. If you divide by 3 over 2 and you want to change it around, if you take it to the top, it becomes 2 over 3. So that is why we have a 2 over 3 there. But 2 divided by 3 would have also given you that. So the only difference between these two is that the one is positive and the one is negative. And I think so that is why. So again, if you say t minus 3 over 2 at the top, so if you want to make that nearly a positive, you take that to the bottom, and it is that. But t minus 1.5 would have also been correct, which is there as well. So the only difference between 1 and 3 is that the one is negative and the one is positive. And if I worked with my mistake that I made there, I would have gone for option 1. So yes, very easy, one can make a mistake. And I think that is just again showing how quickly one can make a mistake. And you will actually, I would have completed this and my answer would have been one of the options, and I would have thought I have it right, and actually I don't. So yes, just be very careful, especially with the positive and negative. Okay, so that was option 3 for 2025. Any questions on that, or can we just continue? Okay, why change to positive? Remember, we always say when I add the 1 here that we need to divide at the bottom. So at the top it was minus 3 over 2. So I need to divide by the minus 3 over 2. So this term will be negative, and there was a negative there. So the negative times the negative there gives me the positive. Okay, happy with that? So it's basically that it's the negative times the negative that creates the positive. Okay, cool. Okay, any other questions? Please, I don't mind to explain. It's important that we get this right, because it's easy to make a mistake, especially with the numbers or the signs. I think that is you saw how easy I made that mistake, and it's just and unfortunately with this subject, there is normally an answer with a mistake that you made, and you in the end think you are actually getting it right. Okay, let's go to the next one, which is a more difficult question for me. Or I thought it was a difficult question. So wait. No. So let me quickly, I'm going to take this out in the recording. It would be in any case. So remember, Nicola, so when we do integration, so if I had, and let me do it like this, that you can just see. So, and let's just work with a positive. So with integration, basically the rule is I need to add 1 to the top. So I'm going to do it straight through. So t to the power of 2 will become t to the power of 2 plus 1. But then I need to divide by that 2 plus 1 at the bottom of it. So the same if there was a half or minus a half, I need to add 1 to that as well. So it would be then t a half plus 1, and then I will need to divide that by the half plus 1. So that is just your integration rules. The reason we add the c is because this was, and let me take, I should not put the c there. The reason why we add the c is that, and I think that again is just important as well. So your original could have been this. So if you differentiate, the 4 would disappear. So if you then integrate back, you don't know if there was a c or not. So that is just out of purely maths that we add back the c, and that c can be anything. So even if a c is then 0, it's just to show that we remembered that there is a constant that we maybe need to add. So that's the reason for the c as well. So it is just purely out of maths. You don't know if there was a constant. So even if that constant then in the end will be 0, we just need to show that we actually do remember that there is a constant. So that is why we do use the c. Even if you look at the 2 other numbers, it was totally wrong in any case. So in a sense, yes, I did cancel those 2 out, but in a sense, t to the power of 6, and there it would have been t to the power of 7, also would have been wrong in any case. But that is basically nearly the c and how we got to that one. Okay, next one, question 26. So what do we need to do here? So let's look. A tool hiring company has estimated that the rate So when we talk rate, I automatically think integration or differentiation. Rate of increase in the maintenance cost of power draws is given by the equation, where T is the time for the company is in operation for weeks. Calculate the total maintenance cost during the first 4 weeks. Okay, so basically we need to find out what is the maintenance cost from week 0 to week 4. Okay, so how would we do that? Let me just get my calculator here as well. Any takers for this one? Nobody. Nobody want to try their luck on this one. Okay, doesn't seem like it. Okay, so and let's quickly just do two things. So if I would have just said, let's use that formula, let's put in 4 into T, you will get the answer. Okay, so you will get the answer for that, and then that answer would have been 10. But that is not what we need to do. So basically, we need to get the integral of this formula. So we need to say, what is the integral from 0 to 4? Okay, so Trudian, did you just say you basically substituted 4 into that, and then you got the answer of 10. Okay, so let's quickly. So you need to get the integral of that. So what is the integration of that formula? Again, open to the floor. I think this is how I would have been in the class if we had our face-to-face class today. So please, I think we're still a small group this morning. So please, how would you have done this? If this was in the exam, what would you have done? Anybody? Come on. Okay, nobody gonna take this one. Okay, so what's the integration of that? Really nobody. Okay, so integration. If we integrate that, what do we get? No, man. No, you can't be that quiet this morning. Okay. So what do we do if we get that integration? Okay, so let me get me back to so what does the rule say? Is it 1.5 t to the power of 1.5? Is it that? Is it 1.5 t to the power of 1.5 plus 1. I want to, so what would you have chose any of those two? You guys are very quiet this morning. Where's Wendy? Is Wendy or Siska online? Okay, nobody. Okay, second one. Thanks, Wendy. So you would have chosen that one? I see. Afraid to give answers this morning. No, but don't worry. It's part of rather try and we get it wrong than in the exam get it wrong. Okay, so if you said that one, so what happened to the two? I just want to get understanding. So would you have said that would become 2 times t, or would it have just disappeared? Or would it just have added to? Okay. Okay, so let's do this. So let me just quickly erase. And if you have a calculator for this, it would have been also very, very simple. So yes, so let's see. Yes, I think there is the right one. Awesome. Okay, so we need to integrate that. So, and basically we have, and why do we have 2t? So let's just do that to the power of 5 over 2, y 5 over 2. I'm still thinking if that is correct. Okay, so 5 over 2. So as Wendy, you said the 1.5 plus 1. So that gives you 2.5. 2.5 is actually 5 over 2. So if we have that, we divide by 5 over 2. Okay, so that's just the normal rule. I like that website that you're using. That is, please, if you haven't shared it yet, please share it on the WhatsApp group. That is an awesome website, which takes away all the problem that we will have in the exam. Okay, and then you basically, where it was the 2, so the 2 will become 2t, and yes, we plus c. In this instance, the c will be 0 in any case. So then you plug in, and they set the 4. Remember, what we need to do is plug in the 4, get an answer, plug in the 0, and you subtract the 2. But if you put in 0, it will be 0. So that answer will nearly fall away. I think 0 to the power of that will be 0 in any case. 2 times 0 will be 0. So whatever your answer is here, it will be the answer. So when you say 5 to the power of 4 to the power of 5 over 2 divided by 5 over 2 plus 2 times 4, there isn't a value for c, so that is actually also 0. So we don't worry about the c, because in there it would have been a c as well. So c minus c would have given you 0. I hope I'm not confusing. And then your answer would be the 20.8. But please, that website is actually quite cool. I just saw that now in the chat. That is, yes, how do you get to the 2t? Remember, so what happened to get to 2t is that you're sitting with 2, so we know that the rest of the equation was t's. So you basically need to say, how do I get from 2 back to whatever is in the rest of the equation? So if in the rest of the equation there was x's, it would have been 2x. So you basically are integrating. So and Wendy, let's do it this way. So actual fact, what you have there is t to the power of 0. So t to the power of 0, okay, cool. So then you would have just added the 1, like we do with the other ones. Okay, awesome. But that website, please, I recommend that. And you can nearly do all of the integration questions with that. So it doesn't matter even if it is just to the power of, if there was ln, you can do it, the ease, you can do it. So I actually like that website, and please use it. Even with this one, do we already have an answer for this one even from that website? Because that again would have been quite cool. Okay, so we need to integrate. So if you look at the integration, all have C's, so all of them, so I'm not even cancelling anyone out at the moment. So let's first, again, I would want to make it a simpler formula before I start to work with it. So I would have said, okay, so let's quickly check. I would have divided that and that. So that is what I would have done. I hope I'm actually right. So it would have been 1 there on this one. So that would have been x to the, and if I divide that by x, shoo, that is, okay, so let me get more space to, so basically what I'm doing here, let me just, I'm first simplifying that one, and then I'm simplifying that one, that I don't work with one on top and the other one. So basically I want to see what is that divided by x, the simplification of that. So I've got x, what is that cubic root? I don't know how to say that in English, but that is what I would have done. Then remember at the bottom, so that is 1. So if I bring that up to the top, it is a third minus 1. So I'm not integrating yet, I'm just simplifying. So that is x to the power of, okay. So my equation here then is just a bit simplified so that I can work with a simplified equation. Okay. So then basically the same principle, we're working with x's, so that would have been originally x to the power of 0. So if I do that, it's x 0 plus 1, so it's x1 divided by 1, so it all stays just like that. So then if I look at before I even get to that one, okay, where's the X, where's the X, where's 1, where's 1. Okay, so basically for the exam, then I would have said, okay, I would have picked option 1 or 2 out of this one. So let's do that one. So it's x2 over 3. Remember that I add 1 as we did with the other, so that becomes, and I'm not going to write it at the bottom yet, so that becomes x 1 over 3, which in actual fact was that, but let's not, it's just by fluke. There's no, it's not any scientific method or anything, it's just how it was structured. So so then I know I need to divide it by the 1 over 3 as well. So basically I've got here, so I can rewrite that. Yes, I like that website. I'm gonna steal that website because that is actually awesome. So that I'm rewriting as the original that we had there. And then I'm dividing by 1 over 3. So if I said divided by 1 over 3, remember if I divide by 1 over 3, I want to bring it to the top, it turns around. So then basically this equation becomes 3x, and there's a 3 in there, so it would have been option 1. Is that the same that we got in the, yes, awesome, and you just add the C, so it's the same that we get in the on the website. I like that. So please use that website. It would save you, imagine you use that website for this exam, so you could have done it there, probably there as well. So there was, and I assume you can do differentiation on that as well. Otherwise, there will be a website for that as well. So there was nearly, for all of these integrations, there's a cool website to do that. Okay. So let's look at the next equation, and also seems like integration again. So let's just quickly see. Okay, thanks for sharing both websites on our WhatsApp group. Awesome. So basically your integration and differentiation is covered by those 2 websites. So on that day of the exam, have them open already, but you guys also download the paper. So it's actually cool. So you can write it on the paper. Don't worry. I think, don't stress too much. This is probably the most difficult it will get. So yeah, but please use the website that it doesn't clap you into another zone. Okay, let's look at the marginal. So the marginal labor cost function is given by that, and calculate the cost of employing the first 7 laborers. Okay, I just quickly want to write down your cell phone number that I can add you. I will later on give my cell phone number as well if I forget. Okay. Okay, so let's, what would you do here? So basically, again, we'll do integration. So remember, sure, when did we do that? Like nearly a month and a half ago. It's one of the first 2 or 3 sessions we did, where we looked at that table when it's marginal costs. So to get from the one to go to the other one. So if you need to work out marginal cost, and you need to calculate the total cost, nearly you think you integrate. If you move to the other way, it's differentiation. So just again, it is in one of the study units, but you just look at that table. I will just flag it again. I think it was study unit 5 or 6, where that was, and then the rest of the study units as a cool. Page 105 in the study guide. So let's just write it down here as well. Page 105 in the study guide. Okay, so basically integration. So we need to, and let's look at for the first 7 hours. So from 0 to 7. For L. So, and it's, okay. So, and it doesn't matter what your, if it's a L or V or U, that website, you just, in a sense, use, maybe it will be, I haven't looked at all the answers, if you can actually just put in L and those things, but otherwise you use the standard X's and Y's and things like that, and you in the end just substitute again. Okay, so basically we need to integrate that. So how I would have done it, my integration would have looked like 3L plus 4L to the power of 2 divided by 2. So that would have been just then 2L to the power of 2. Okay, cool. The website even uses any letter that you put in. Okay, so that would have been my integration formula. And then again from 0 to 7. So, and let's do this one fully. So let's just, let's add the C. Let's just say then from 0 to 7, so that we get everything. So first put in the 7, so it is 3 times 7 plus 2, 7 to the power of 2. And remember that is the L value, so here you have a C. Okay, so that is the one formula, and then you say subtract where it is the 0. So replace that with 0, so we basically get 0. Replace the L with 0, so basically we get 0. And here we've got the C that we don't. I just want to show what happens to the C and why you can, when you integrate and you need to replace, you can nearly don't need to work even with the C. So here we've got 21 plus, sure, okay, what is that, 49 times 2. Okay, now I need a calculator for that. So it is plus 98. Okay, so let's say plus C, just to show. Remember there's a negative, so negative times positives will give you the minus C. So in the end that is 119. C minus C is 0, so you will end up with 119, which is option 4. If you, and that's unfortunately how it will be, so if you replaced 0 here and set the 7s on this side, so if you swapped it around, the negative 119 would have been your answer. I don't know how they would have gotten to the 114. I can't see a way of getting there. So maybe there was something in the formula that would have been okay. So, but that is basically the two that you would have done here, and this was just to show again why when we replace it with values we can actually eliminate the C from the start. I agree, it is great tools for the exam, specifically because this one is online where you can do it at home, because when you go back into a normal exam location, you won't be able to have those tools available again. So please use as much of those online tools as you can for the exam. Okay, so let's quickly look last two questions and then we can go back to question 23. Okay, so, and let's see if I can make this a bit bigger. That we don't need to have as big, so let's quickly that. Okay, so basically in question 29 they give you the formulas and you need to decide in the end which one. So in this one they give you the inequalities and they say, okay, was drawn and the feasibility region. Okay, so all of them are bigger. So basically, oh, so this is a bit different. So let me read this from the beginning. So in the graph below, the following set of inequalities are given. That was drawn actually, and this is the given. That is given. So that is how it looks like. Then they tell you, determine the minimum value of a cost function subject to the set of inequalities above. The minimum cost is equal to. Okay, so how I would have done it is, so in this, you basically have 3 points that you can check out. So it's or A, or B, or C. It's interesting if there's another way, but this is how I would have done it. So then I would basically say, let's put in the value of C in there. Let's see what's the answer. Let's put in the value of A in there. And let's put in the value of B. But with B, we still need to probably calculate what B is. So hopefully by putting in A or C, we would get maybe the lowest one. It doesn't always mean that your answer pick 70 because it is the smallest number. So just remember that. So let's put in, so if I look at point A, the values is x is 0, y is 10. Okay, so that is your y cutoff. So if I do that and put it in there, basically my answer is where x is 0, so that will fall away. Y is 10, so the P will be equal to 120. So at that point, it will be 120. Let's look at if I use that point, so that would have been where x is equal to 10, y is equal to 0. So if I put that in, I get y 0, p is 10, so that gives me 90. So at least I know 90 thus far is the smallest. So then in the exam, between 70 and 90. So let's look at that point. They haven't given us that point, but they give us the two equations to work out that point. So the one was, and let's make a bit of space here. I'll write it there. So the one equation was the 2x plus y is equal to 10. So it was that one. So let me rather do it. So basically it was with 2x plus, so it was that one, and the other one was that one. So if we want to say, okay, this is quite interesting. Okay, so if we need to calculate, okay, this is quite a weird one. I just want to write that out. Because that then basically would tell me that if both is equal to 10, then 2x plus y must be equal to x plus 2y. Okay, so that doesn't help me unless I try to solve it the way that we've done it with previous questions. Yeah, so that is, so basically what I then would have said, okay, so if I let me do it that way still, let me just see what we get. So if I said, because both is equal to 10, it will be interesting just to see what we do get. Because if I then take all of the x's to one side, that becomes negative. So x is equal to, and that goes to that side. So basically we know that y is equal to x. Okay, so that doesn't help us at all. But then because we know y is equal to x, we can substitute it into one of those. So I would say, okay, we know y is equal to x, so I'll substitute the y or the x there with y. So y plus 2y is equal to 10. So 3y is equal to 10. So y is equal to 10 over 3. And because y is equal to 10 over 3, x is also equal to 10 over 3. So then if we put in the 10 over 3 into that one, and if we put 10 over 3 into that one, basically the answer that I am getting (10 divided by 3 times 12) gives me 40 for that one. 10 divided by 3 times 9 gives me 50. And that gives you 40. So actually, right, or added those together gives you 70. And then it is the smallest one. Okay. We are not doing any paper. We are doing assignment 3 of this year, which was actually, I think, 2018 October, November exam paper. So it is nearly a replicate of one of the exam papers with 2018 end of year exam paper, but it was also your assignment 3. So actually it was 70. So strangely enough, that was the answer. So if it was the Muhammad method, he would have gone for 70 and he would have been right. So I just think, again, I thought it would probably have been one of the others. I would have thought, because it was such a weird number that we work with, that it would have been maybe option 3, but not. So 70 is in the end the minimum cost. Just in the exam, just be that it's not, because that was the smallest one that you could pick, doesn't mean it will be the smallest one. So just for that instance in the exam, please don't just go for that one unless you don't have time, and then go for the smallest one. Okay, so let's get to the last question. So what I think is important to note also with question 30, and that's why I think this was really a difficult exam nearly, is that we are used to the formula as x plus y bigger or smaller, kind of. So here, all of the equations, and let's see if I can make it just bigger so that you can see. So all of these equations are written in a different way. So what I would have done with this is I would have rewritten it first, so that one can make the correct assumptions. So I would have said, okay, equation 1, if I rewrite it, it would be, the half would go to that side, so it will be a half x plus y is bigger or equal to 2. The same with that one. What I would have done is say minus x plus y is smaller or equal to 3, and that one stays the same. So I would have just rewritten 1 and 2, so that I can make the correct assumptions around that. Okay, so when we look at the options, so let's start with that option, because you will see even in, where was it, in this one, they also have that option. So that just means that when you're looking at these options, your x will be, and normally they would tell you x and y, but here is a different one for y. So in this instant, all that this is telling me is your x values will be bigger than 0. So there will not be something in this area. So if one of the options was given there, we could have eliminated it. Okay, so let's look at what they tell us in that one. So here they tell us that y is bigger than 0. So y needs to be bigger than 0. but y is also smaller than 4. Okay, so y is smaller than 4. So there can't be a situation like this one where you actually go past 4. So option 4 is not one of the correct ones. Okay, so you can't have it that it goes past 4, so we know it is between 0 and 4. So all of these are still options that we can work with. Okay, but at least one we have now taken out of the equation. Okay, so then I will work with that one next. So in this instance, what I would do is I would say, okay, so let's look where y is 0. What is my x value? So my x value is 4. Okay, so where y is 0, x is 4. So it seems like we're working with that equation. Where x is 0, y is equal to 2. Okay, so we are working with that one. So we're working with that and that. So what that tells me is bigger or equal to 2. So in my, it tells me it needs to be bigger or equal to. So I'm sitting with equation where it tells me bigger or equal to. So it needs to be bigger or equal to, bigger or equal to. So those two are still options. Bigger or equal to. So this one, again, I can eliminate because my area should be there or there. It can't be there. So option 3 I can eliminate as well. So basically we sit with all that area or this area that I need to work with. Okay, and then the next one is, so where x is 0, y is 3. Where y is 0, x is actually minus 3. But it's smaller or equal to. So it's actually telling me it must be that area. That area. So it's not that area, so we can eliminate that one. And that is why we then basically have option 2 as the correct one. So it is sitting in that gray space. Okay, so that was basically how we got to that. And again, it's easier when we have rewritten it to get to that than if you have originally worked with this kind of two formulas. So it's easier for me to say I rewrite it as this, and then I can work with it, and then I go with it step by step. I don't know if anybody has found a nice website for this one, but yeah, so basically, oh man, this is awesome. Okay, this is perfect. So share this website as well. It's basically you telling me that I don't need to do anything. It's just share all the websites and you guys will be fine. Awesome. Okay, so that is actually quite awesome. Okay, so that was question 30. I just want on that website, does it also then show you the region that you need to accept? So that would have been, I assume so. I assume they would then say color in the area that it represents. Or if I say, yeah, I assume that is what they would do then. Okay, that is awesome. So let me quickly, I think we've run out of time, but let's quickly check question 23. That we just finish that off. So this is actually also you need to find the derivative. So please do that on the website, and let's quickly see what the answer is, because yeah, question 23 option is 1, but I'd quickly, because I've written it down for me, and I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, nearly 12 steps to do question 23. So I'm like, if you just put that into that calculator and you can get that so quickly, it would be awesome. So just what we will do is I just will quickly give you, so when we derivate this, okay, the 14 will disappear because that's a constant, so we need to work with this one. And that I would, again, if you look at that, you're sitting with 2 equations in it. So you would need to define one as U, you need to define the other one as V, and then you will use the product rule in there, and then you will solve it. So again, that takes quite a lot of time. So if we have that on the calculator that one can solve it quickly, then it is a win situation. So in the exam, this will, awesome. So in the exam, this will take me probably 10 to 15 minutes, where it was very easy done with a calculator. Yeah, so simply rewrite x plus 10 over 2x, x plus 5. And they even give you on that website alternative methods of writing it, which is also awesome, because if you use it, yeah, so I would have just, if I didn't have a website, basically you do it for the product rule kind of way, that you need to put in the one, you put in the, so you say x is equal to u. So that is actually awesome, that website. So please use it in the exam, specifically because what I've now seen also is it gives you an alternative result. So, and it can be sometimes that in the exam you get it that they write it in 2 or 3 different forms, and then it is one of those that you can also select. Okay, so that's the end of today. For I will just check with Unisa that we can schedule a time in the week as well. Then we'll do, I think it was the question paper that was shared on the group was, I think, the June 2019 one. So I think that is a good one to work through. And then I'll see if we can maybe work that somewhere next week, then next Saturday, and then hopefully Monday we'll do just before your exam a catch up. Okay, any other questions that you quickly want to ask, or are everybody happy? I just want to, oh yes, for the guys that are not always possible to see all the chats and the email number or the SMS numbers that you're giving me. So my cell phone number is, now I must remember, 083-790-8387. So you can send me a WhatsApp as well if I haven't added you in the next hour or so. So I will add you to a WhatsApp group, and then we will just basically we are chatting about the exam and things like that, and we are sharing things. So please, yes, if you want to basically be added to that, send me a WhatsApp. I think I've got one or two of the ones that that have shared their numbers, so I will add that. Charlene, if I pronounce your name correctly, please can you also share the 2019 paper on the group as well, because I don't have access to the previous exam papers, so it will just be nice if I can get access to that. So please share it on the group as well, and then I can look at some of those questions as well. Okay, and that is it for the day. Have a great Saturday further, and then you will get communication about when the next session is. I'll just check, and I'll ask the group as well how your schedules are at the moment and when you're writing. Okay, so let's just basically that is it. I'm going to stop the recording now as well. So hopefully that will be